Okay, so in this tutorial, I will explain or talk about the character level based LSTM language model. So let's just get started. So we imported the libraries, the most important libraries, and that we have to use in our code, and then you can use any arbitrary text. So here I used this text from this website. Um, so the basic idea, so first let's just introduce the language model. So the language modeling is the task of predicting the next word in a sequence of words. So in our case, which is in this tutorial, we are trying to predict the next character given the previous characters in the sequence so far. Okay, so this will be like we will make clear in later in this tutorial. So let's first prepare the data. So we have our text, as we said. So first, what I will do is, just trying to make this text in like one sequence. So I want that text to be in a single sequence, okay, to be more easier for the subsequent processing. So let's just say we have like the tokens, and we just need to take that text and split it. After splitting the text, we need to just join it a space, so because we want a single sequence. So if we just print that row text, we can see that, okay, so we haven't, let's just run this. Okay, so we can see that now we have a single text, right, without like any new line and spaces and so on and so forth. Okay, so now let's prepare our vocabulary. So we know that our task is a character level, right? So all we need to do is to take the set of our text, and this will give us the unique characters in our text. So over this, we need to, convert that to like a list, and then we just need to sort this out. Okay, so this will be like my characters. All right, so if we just print that, okay, so we can see the unique characters in our text. So the next step is to define the dictionary. So what is the dictionary in our case? So we want to assign each of these characters a unique integer. It's a mapping, okay? So we will have a dictionary. In this dictionary, we will have the character and the index for I and C in the in enumerate chars, our characters, right? And then let's just print the mapping. So we will have here, each character will be assigned a unique integer, right? So this is my mapping, which is the dictionary, and now we want to have our vocabulary. So our vocabulary is nothing but the length of mapping. Okay, so if we just print the vocab, it is 35. So we have 35 unique characters in our text. All right. So now let's, before like encode the text as integers, let's just prepare the data. So first we will have a length of 10, and this length is the length of the input to the model. So we will have like the number or like the sequence of characters as input to the model will, like the length will be like will equal to 10, right? And so the output will be the element, the element, element in the sequence. So for example, if I have hello, yep, hello, for example, world. Okay. So we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be the input to the model, and D will be the output. In the next sequence, we will have this as input, including the output from the previous one, and the output will be this space, and so on and so forth. We will offset by 1, okay? So this is the length. And now we will, have a sequence. So we will have sequences, which will be a list that we will use later, okay? And then we will start looping. So for I in length, sorry, for I in range, it will be the length and the length of our row text. So we will have a sequence which will be the row text of. Here we will have like a sliding window. So we will have I minus the length, and then we will have our offset, as we said, by, well, this is the like by 1, and then we will take that sequences, which is our list, and trying to append, right? So we will append that sequence, okay? All right, and then let's just print the sequences. Okay, so what is the basic idea here? So first we have a list, and we are looping through the range of the length, which is from 10 to the length of the row text, okay? And then we just do a sliding window, as I said. For example, we have the first 10, right? So we have the first 10, and this is the output. And then in the next one, we will have it like this, and then it will like including the output from the previous step, and this is the out. So it will be like very clear here. So for example, if I have this, so this is the 10 of length 10 as input, and this is the output. In the next step, I will use the output in the previous step as, in the input, and I will offset by 1, okay? And then I will have this, which is my input. So this is the, context window. And then what we will do is, appending that sequence. And now we have these sequences ready. So now, after having this, what we have to do is to encode these and looping through these to assign each character a unique number, okay, or a unique integer. So we just need to have, let's just have, okay, so we'll have a list, and then we will loop. So for sequence, just loop through these sequences that we have here, okay, to assign them a unique integer, as we said. So we will have the encoded sequence, and it's nothing but like a comprehension list. So we will have a mapping of cha for cha in that sequence, right? So for sequence in sequences, okay, what we will do is taking the mapping which we create here, which is our dictionary of the character. For example, if we are here, so we are taking the mapping for each character here, okay, in the sequence. Why? To assign that, as we said, an integer. So we will take our sequence and we just need to append that encoded sequence. Okay, so let's just print that new sequences or new sequence. All right, so now we can see that this, for example, it's like, let's just look at the first one. So we can see that it just converted into number, unique integers. So we can see here that we have the, I mean by unique integers is that, for example, D will have a unique integer in all of these. And then we have S, it will have like one unique integer. Okay, so for example, S here, and we have S here, which will have the, okay, for example, the same integer. Okay, so this is how to encode it in general. So now in integers in general. Now let's prepare the input and the outputs. So all we need is to just use the numpy array to convert the new sequence that we have into an array, and just let's import numpy, and then we will have our x and y, which are just the sequences, okay, where we will use the, okay, let me just write it and then I will explain that in a bit. Okay, so what we are doing here is taking all the rows and then all the columns except for the last one. Okay, so we have these lists. So as can be seen here, we will take all the rows, okay, but we will not accept the last one. So the last one will be in the array, of the output. It will be in the output array. Okay, so x will be from the beginning, except for the last one will be in the y. This is for the first example. In the second example, we will do the same until the last one, okay? And then this will be taken into the y array, okay? So this is, how to prepare x and y. To make that clear, let's just see. So this is my x, as we said, until 23. And then this one will be in the y. So let's just see y, which is the 28. So we will have here 28. And then, as we said, we will have this all the way until, except 19. And then 19, we will have it in the list, or in the output, which is the y. Okay. Okay, great. So now the step, of one hot encode the x and the y's, in order to make the representations more efficient and more precise, for the network. So let's just create that very quickly. So we will use the two categorical, so two categorical from keras.utils, right? So it's just from keras.utils import to categorical. Okay. So here what we will do is to categorical of x, where we have the number of classes. So number of classes is nothing but my vocab, okay? And this should be like a list comprehension, right? So for x in x capital. And then we will have our x, which is nothing but, sorry. So we will have our x, which is the numpy array, and we will have these sequences, just converting that to numpy array, and then we will have the y, which is the two categorical, right? It will be for y, and then we have the number of classes, which is again my vocab. Okay, so the number of classes is my vocab. The um, you know, like in each, for example, in X, we will have for each for each character, everything will be zero, unless that position which is corresponding to that, for example, character, it will be one. So for for a specific character, we will, like in that position, like in that word, for example, for that specific character it will be one, and the rest will be zeros, right? And also we will have that for the labels. And so we specified here the number of classes to be our vocab. Okay, so this is the let's just have a quick look. For example, here we can see the X and also the Y is this the same way. All right, so now it's the time to define our model. So it will be, as we said, a long short term memory. So let's define a function, create model. So we will give this model our X, and it will be a sequential model. So we know that we have functional API and we have sequential. So here, since we are not using like two inputs to the model, so it's good to to use sequential. So we will use bidirectional. We know what is the bidirectional long short-term memory, which is the LSTM model, condition on both directions. So we have the LSTM, and we have like 50 memory cells, and we will have the input shape here to be the X shape of 1, and then we will have X shape of 2. So the X, let's just have a look. So the X shape in general is we have this size of the text that we have, and we have 10, which is the length, the maximum length for the input that we have, and then we have the vocab. So this is the maximum length, and then we have the vocab. So this is our inputs, and let's just import these libraries. So we have Keras, and then we have from TensorFlow, or let's say import TensorFlow, and then let's just from TensorFlow dot all right, so let's just continue. We will have the output. So it is very simple architecture, and you can of course experiment with whatever you want. So here we have the vocab, right? So in the dense, this is the output. So we have the vocab, and then the activation will be soft max. Why? Because this problem is a multi-class classification. So we will have, for example, the input, and then we will have encoded that using the LSTM, and then we will pass that to the dense, and this dense will contain neurons equals to the number of unique characters in our vocab, which is 35. Where using the softmax we will get like probability for each and every character to like generate it or to be the next character. So there we will just compile. So model compile. So the loss function will be the categorical cross entropy, and this is because we used one hot encoding here. Otherwise, we will use sparse categorical cross entropy. And then we will have the optimizer, which is the atom, right? And then we will have the metrics, which is the accuracy. Okay. And then let's just return the model. Okay. So now let's just create, like, calling the function with x. So we will call it with our x, and then we will fit the model. Okay. So we will fit the model on x, y, and then the epochs, let's give it 200. Okay. All right, so it says that object is not colorful, so we have like a problem here. So we have, okay, so we have this problem, should be brackets. Okay, so now I will stop recording until we finish the training, and I will get back to you. All right, so now that we have we finished the training, so now let's start generating sequence or characters based on a given sequence. All right, so let's define a function called, for example, generate sequence. Okay, I will give it the model, the trained model. I will give it the mapping, and we will have the maximum length, and we will have the text, which is my text, and also we have the number of characters. Okay, so first we will have our text, let's say is the text, and then I will just write this very quickly, and then I will explain it. Okay, so so far so good. So we have the text, right, that we want to generate, like complete it, right? So we just loop through how many number of characters you want me to generate for this text. Okay, so how many number of characters you want me to complete this text with. Okay, so this will be will be made clear once we have an example. So first, we know that if we have any input like to this model, we have to pre-process it in the same way we did for the training. Okay, so what we did previously is using the dictionary in order to map every character in the text. Using this dictionary we want to map it to like an integer, right? And then in this case or here, we will since we have a fixed, and we know that neural networks expect that the input should be like in a fixed length. So the fixed length that we have in our network is 10, right? Sorry. So the fixed length is 10. So our input here to the model must be of the same maximum length. So what we will do, we will use the pad sequences, right? From Keras utils. So we will have encoded, and we will pad sequencing that, right? So we will have our encoded, where we have the maximum length is nothing but the maximum length that we will specify, and then we will have the truncating. So truncating, we'll use it as pre here. Okay. After that, what we did, we hot encoding that, right? So after doing that, we apply the one hot encoding. So let's just apply it. So we use two categorical. So two categorical over that encoded text, where the number of classes, equals to our vocab. In the same way, exactly in the same way. And if you want to use the model, later, not in the same session, to generate, for example, sequence of characters, you have to, dump that. You use like the pickle, and then try to save the model, and also, dump the mapping and so on and so forth in order to use it later. Okay, so now we will do like the prediction. So we will use our model, okay, given here. So we'll use the model to predict, and we'll give it this input. Okay, after prediction, we will find the highest, probability, which will be like, we will choose here the, the index of the highest probable word or next word. So we have already the numpy, and we just need to use the argmax to find the index. Y hat, and then we have the x's, right? Okay, so then we will have like the output. So the output is just, an empty string, because we want to loop to find that. So for char and index, in the mapping dot items, so this, like, we will ask if the index equals to my y hat, then we will take our output and put that char in it. Okay, so we will just loop through the mapping, and then if the index, which is the y hat, if it is like, if we get the index which corresponding to the y hat, then we will take the corresponding character. Okay, and then we just need to taking that text, which is my text, and then append that character to it. Okay, and that's it. We just need to return that text. Okay, so we just need to use this. So let's just call the function on some text and see how things will actually go. So we have our model, and then the maximum length is, as we said before, we have the number of characters. For example, I wanted to generate 30 characters. Okay, and the text, let me just see. Okay, so I want to say, okay, sense of the data. Okay, so let's say, let's say data is an. Okay, all right. Okay, so consequences, we have an error. Okay, so we have encoded the mapping and then, but the sequences, yeah, right, so we have to give it a list. Okay, should work. Yep, so we have numpy .org, sorry. Okay, so now we can see that it actually generates the sequence as I like requested, which is 30 characters. So this is the input, and then it completed that, as we can see. All right, so that's it, and I hope that you enjoyed and learned something from this tutorial. Thank you.